Okay, here is our second set of notes for the week. We're going to be looking at what are called lines of best fit. Our EQ is how can we use a scatter plot to make predictions about what might happen in the future based on our data that we're looking at. Okay, so here we go. So I would love for you to think back, pause the video, think, and what's the difference between positive and negative correlation, and then explain them completely. And you could also add in the what does it mean to have no correlation also. So I'll let you pause it and then come back. Okay, so hopefully you paused, wrote that down. Okay, here's some vocab for us. Some that we've already looked at. So correlation. So correlation is an association or pattern formed between two variables. So when they have something connected, they correlate. Okay, whether it's a positive correlation, negative correlation, or if there's no correlation. Okay, data is going to be any set of numbers that we're looking at. Our domain are the X values. Your line of best fit, that's what we're going to be looking at today. That is a single line that approximately fits the scatter plot. So you had all these points, and so it's not going to go like this, right? It's going to be a single line that goes through it to the best it can. Your range are the Y values. And then a scatter plot, I showed you on the last set of notes, a scatter plot is your graph that shows data from two variables using points on a graph. Okay, so if you want to pause and write these down, go for it. I think that would be really useful. All right, so how can we estimate a scatter plot with an equation? Okay, so usually a graphing calculator or computer would be used to have an estimate of your equation for a line that best fits the scattered points. So a line that best fits is the line of best fit. Okay. So line of best fit is what we're going to be calling it. It could also be called a linear regression line or a least squares line, but we're going to be looking at what we call the line of best fit. Okay, so all the same thing. We're just going to use the top one is what we call it. And then I wanted to add, we are literally going to see equations of lines. Okay, so we're going to use literal lines and equations. So remember back in the day with y equals mx plus b? That's what we're going to be seeing. Okay. Okay. So what lines of best fit apply to each type of correlation? So what were our three types of correlation? We had positive correlation and negative correlation and no correlation, right? So when you have positive correlation, you should have a positive line of best fit. And what it means for it to be a positive line, the slope is positive. Okay, so y equals m is the slope, x plus b is the y-intercept. So if you look at this line where it would cross the y-axis, it would cross at like 1. So that's why you see the plus 1 there. And then the slope is a positive 1/2 because it goes up 1 over 2 and so on. But you'll notice this line does not cross every point. That's okay. All right, we're drawing a normal straight line. We are not connecting the dots. Okay, so single line that goes through the best it can. And a positive correlation graph would have a positive slope for the line equation. All right, so similarly, or opposite, I guess, a negative correlation would have a negative line of best fit. So this line, see, when it goes through, it's going to be going down, so it should have a negative slope. And then you'll notice that plus b, that y-intercept, now it says plus 10 because this line is going to cross all the way up here. And we're going to pretend that that's 10. Okay, so crosses up here at 10 and then it goes down, which is represented with a negative slope. Okay. Pause it, write this stuff down, get it all in there for your notes, okay? Okay, how can you tell if a line of best fit is correct? So when you look at these three things, okay, so you'll notice A, B, and C each have the same dots, the same points. Okay, so da la la, da la la, da la la. Okay, and so we're looking at, okay, A, B, or C. Which line best fits those data points, right? So it says, which of the lines below is the correct line of best fit for the scatter plot? So we're going to look at, it should have the same slope as the correlation. So A is out, right? Because A, the points have a negative correlation. From left to right, they go down, but then the line has a positive slope, right? So A is out. No. B and C both have a negative line of best fit. See, negative slope, negative slope. From left to right, they're going down. So here, the second bullet point, the line should intersect as many of the scattered points as possible. So if that has to be true, does B intersect more points or does C? C does, right? B, it kind of goes through those two, but that's it. C, it goes through 1, 2, kind of 3, 4, 5, so around 5 or 6, right? And it's it kind of matches the slope of the data. So C is what the line of best fit should look like. Okay. And I think that's it. No? Yeah. So that was it for our line of best fit. And so I'm going to post this PowerPoint on Google Classroom so you'll be able to watch the video, and then the answers you'll be able to find on the PowerPoint. Okay. So see, well, like, anyways, so use the practice worksheet, practice stuff with scatter plots and lines of best fit. And then the worksheet for this one, it's all, I think it's all multiple choice. So you could just write your answers down and then check them with the PowerPoint. And then just post your answers for me so that I know you tried. Okay. Let me know if you have any clarifying questions, and I'd be more than happy to answer them. Like I said on the last video, Tuesday and Thursday, 11 a.m. at Zoom. Or you can ask me questions on Remind anytime you want. All right. Have a good week, everybody. I love you. I miss you a lot.